In this video, we'll talk about introducing you to the R for Data Science book and the chapters that are going to follow. Here are the learning goals for the lab. In this video, we're going to outline the steps that we encounter in a typical data science project. We are going to understand the order of those steps that are covered in the book. And then we'll also talk about some of the topics that aren't covered by this book because you would have to consult other resources. Primarily that relates to modeling. And we will also try to understand some of the prerequisites, but if you're at this stage in the playlist, you probably have those prerequisites under your belt. Okay, so let's take a look at a typical data science project. This entails 6 steps, starting with importing the data, followed by tidying the data, and then trying to understand the data. And this has several different steps, beginning with transforming the data, then visualizing the data, and then modeling the data before you end up communicating the results of the questions that you had set out to answer in your data science project. But encompassing all of these steps is programming in R or in any other language, which is sort of a cross-cutting tool that aids this entire data science process. Now, programming is essential because it allows us to automate common tasks that we encounter in a data science project, and it also helps us solve new problems with greater ease. So let's start by talking about the first step, which is importing the data. Now, you can import data in a few ways. You can import data into R from a file, such as a CSV file or an Excel file. It could be from a database. It could be from a web application programming interface, such as an API, any kind of API. Okay, so the important thing to remember is that we can't really do data science until data is loaded into R. So that is why this is the first step. Now, steps 2 and 3, let's just go back to that picture here where we said after we've imported the data, we're going to be tidying and transforming the data, right? So in steps 2 and 3 combined are also known as data wrangling or wrangling the data, okay? Now, the second step is called tidying the data, and this is when you try to make the data structure consistent with how you would deal with a data science project. So in essence, you want to make the structure so that everything looks easy and simplified, and you can really understand what the data entails, right? So you remember the MPG data set from a couple of videos ago, where all of the columns correspond to some variables, right? So the MPG data set had data on, let's say, manufacturers of cars. They had data on the model of the car, etc., right? So those are the types of variables we're talking about, and those were in columns. Now, when we are tidying the data, we not only want the columns to be in variables, but we want the observations to be in the rows. Okay, so as long as our data is tidied and is presenting itself in this format, we're good to go. And then we can move on to the next step, which is transforming the data. Transforming the data means that you're going to do further refinements to the data so that you can get closer to trying to answer your research question. Okay, so that would entail narrowing in on the observations of interest, right? So we will use filtering, and these are sort of, this might seem like a little bit of jargon here, but this will make a lot more sense when we get to transforming the data in that chapter. Okay, so we're going to filter the data, which is basically we're going to extract or narrow the data down and just pull observations that are of interest to us, right? Not all the data is something we need all the time. So we will just narrow in on what we need. And then we're going to mutate on the data. So mutation is just like you're changing something, right? So in essence, we're going to be creating new variables from existing variables, right? So we'll try to see some examples where we can understand how mutating the data would work. And then once we've mutated the data, we essentially would want to summarize something, summarize some kind of statistics for particular groups or for individuals or whatever, right? So this could be, maybe we want to look at the mean of highway mileage, or the median of city mileage, etc., for, let's say, all the cars that are all-wheel drive. So those are the kinds of things that we could do. But as you can see that, this process, if the data is very untidy, this can be very time consuming just to get data into the right format and then transforming the data so that we are narrowing it down to the subset of data that we care about. Okay, now steps 4 and 5 encompass visualization and modeling. So when we talk about visualization, we basically, we're going to get into this a lot more, but basically a good data visualization can help you find outlying observations in the data or find unexpected things. Maybe you don't expect that there was a relationship between two variables, but you're finding something, and then you want to explore that further. So it can help you raise new questions. It can also help you tailor your questions and narrow it down, and make it more articulate, right? Whatever your research project is. Now, the only downside of visualizing the data is that you can't really put all of your variables on a chart. Well, you can, but you won't be able to make sense of that. So in other words, the downside is that the data visualization part of a data science project doesn't allow us to scale. It doesn't scale well, right? When you have a lot of data, this is not a great thing. Still, you can do that with a couple of variables, or maybe 3 variables, and try to see what that graph looks like. Okay, but either way, we're going to learn about visualization, and we are going to, in fact, we're going to learn quite a bit about different types of charts that we might use. And this is just for reference. There is a whole other book which is in your recommended reading as well, which is a ggplot2 book, which just, it's all about data visualizations, right? And you know that you can make a lot of different types of charts. Okay, now step number 5 entails modeling, and this is very complementary to data visualization. And once you have sort of articulated your question, research question or questions, you can then try to figure out which model is appropriate to use for that particular research question. Okay. Now, the advantage of modeling is that because it's using math and computational tools, it's very easy to scale that, right? You could have hundreds of observations, or you could have millions or billions of observations, or you could have, a few hundred megabytes of data versus you could have hundreds of gigabytes of data, right? Doesn't matter. It can scale really well, as long as you have tidied your data and you're trying to answer that question. Okay, so moving on, the last step is that we want to be able to communicate what our findings are from the research question that we set out to answer. So it doesn't really matter how good your models are if nobody knows about them, right? So this is a very crucial point here. No matter how hard you're working on tidying your data or transforming data or visualizing your data, you have to be able to communicate those findings. Okay, now just this is FYI that the second edition of the book that we are following focuses on Quarto. I have a video on it which you probably have watched. If you aren't able to knit those files into a PDF, go ahead and knit those into an HTML. You would have less of an issue. But you could also use R Markdown, which was used in the first edition of the book. R Markdown is sort of similar. Quarto gives you much more flexibility, but R Markdown is still fantastic. Which again, both of these tools are letting you interleave your code and the text at the same time. So you're able to type in code, your R code, you're able to um, evaluate that, and you're able to show your output, and you're also able to write a commentary on it, right? So you can easily do homeworks in R Markdown or Quarto and turn that in. Now, even though we said that this is the sequence of a data science project, that we always start with importing the data first, the book itself takes a different type of order in teaching you data science. So the first thing the book does is it starts with data visualization and then data transformation, right? On already tidied data. The reason is that, importing and tidying the data is very routine, it's very boring, and can be very frustrating. Okay. And therefore, visualization of the data or transformation of the data gives you a very high return on investment, because you can see where we are headed when you start. Okay. So we will start with data visualization, which will hopefully, with those charts that R creates, you're going to feel very empowered, and you'll be able to see where we are headed in this course. And this is just, again, reminding you that each chapter is going to have some kind of a data set with very motivating case studies. And usually you're going to be shown that there is a big picture before we get into the weeds of everything. There are going to be exercises that you can always practice at home if you have time. And that's just going to be really helpful if you're trying to get good at this. Now, it is important to know what are the topics that are not covered by the R for Data Science book. Modeling we said this was one step in the data science project. This is super important for any data science project, but it is too big of a topic to cover in this book, so it's not covered. There is, however, many other books, including Tidy Modeling with R, that you can always look at. Now, there is one little point I want to make about what this book will teach you. The book will teach you to handle data sets that are less than 10 gigabytes of data. But if you're dealing with big data on a regular basis, maybe for your job, maybe for some kind of project that you're doing, then you probably don't want to work with tidyverse packages, but you want to work with data.table, okay? Which is not what this book covers. But that being said, usually any kind of data science project, even when you're dealing with 10 to 100 gigabytes of data or more, you can always subset or sample that data, to just filter out things you don't need, and restrict it and make it smaller, right? So again, the tools that you're going to learn in this course are going to teach you enough of what you need to know about data science. The book also doesn't go into other programming languages that are such as Python or Julia. These days, data science teams usually use a mix of languages, but my suggestion is that you only try to master one tool at a time and not get confused. Maybe you'll get confused in syntax or something. So if you are taking other classes, that's fine. But the idea here that I'm trying to push is that try to master one tool at a time so you can get really, really good at something. And while I'm saying that, that you can learn a bunch of other languages as well, R is absolutely fantastic, because even if you were part of a data science team, it offers amazing interoperability with Python. So that is just something to know, that you can work with people who are working on a data science project in Python, and maybe R, and that you can work. Similarly, if you're very good at Python, you join a team where they're working in R. Again, both these languages have great interoperability, and you're able to communicate, whether you work in Jupyter notebooks, or you're writing in Markdown, or Cordo. Okay, so with that, let's turn to prerequisites. This is, you're very familiar with this already, but this course obviously requires you to be numerically literate, right? That you can read graphs, you can understand what things mean, what these different R objects are, and try to make sense of that. Now, I do require that you have some basic programming skills already from the previous videos that I've posted, and those were based on the hands-on programming with R book, and that you have R and RStudio already installed, on which I also have videos. You always want to make sure whenever you are coming back to this course after a long time, or you're trying to, leverage this to answer some research questions, that you want to always make sure that R and RStudio are always updated. Okay, there is a cheat sheet for RStudio if you want to look at it. I have the link right here. Now, it's always important that you remember that before you start, writing R code, etc., that you are installing the requisite packages for the different tasks that you might encounter. For example, here I am installing Tidyverse, which is a collection of functions, and actually collection of 9 packages. And just to kind of define what packages is here, packages are just a collection of functions, data, documentation, and these are really important because they can extend the capabilities of base R. Okay, and so anytime you install a package, you only need to do that one time, but every other time you're trying to work on a data science project that requires that package, make sure that you're loading it every time, right? Using the library command. And just so you know that there are different types of packages within the Tidyverse that work very well together, and they're sort of integrated in terms of the syntax, if you will. So it's just important to know what these are. I mean, you don't have to remember these, but we'll try to get into ggplot2, which is the visualization package, which is absolutely fantastic, right? And then we're going to get into additional packages that give us interesting data sets. These are some of the data sets here. You don't have to worry about it just yet. There are conventions that will be used in my slides, also in the book, that any kind of function is going to be written in the code font, and it will be followed by a parenthesis. So here's an example. If I wanted to sum something, then I'm writing sum, which is the function, followed by a parenthesis. Or if I'm calculating the mean or median of something, then I am also putting a parenthesis in front of it, okay? But there are other R objects which can be used without parentheses that you're familiar with, okay? Those also will be written in code font. For example, if we were writing MPG, which is a data set, or maybe we defined X. So those are just without parentheses, okay? And one little sort of point here to mention is that there are different ways in which you can call different functions. I won't discuss this point right now, but there are different ways of calling out different functions. Either you can install a package, load the package, and then call different functions, or you could write it with these 2 colons, okay, which I will describe later. Now, it is important that you know that when you are working with R, that you are going to struggle. You are going to find that there are going to be error messages because you made a silly mistake, or maybe a comma was missing somewhere, or a quotation was missing somewhere, or the plus sign went into the other line, etc. So there are different types of error messages that R might throw. I suggest that you look at those error messages pretty carefully because they are often very helpful and they can tell you a little bit about what error you're making. If you don't think those messages are giving you enough information, I would suggest that you copy and paste that error into Google and try to see what are the different forums saying. And maybe you can catch your error and you can fix it. Stack Overflow is a great place to also look into troubleshooting your code. But these are some of the things that you want to pay attention to when you have error messages pop up, okay? But in general, you want to try to make your code easy to read. That means make sure that you're, giving, you'll see how I'm writing the code in the slides, but it's important to make sure that you are giving appropriate spaces in your code, you're writing your variable names clearly, you're commenting your code so that using the hashtag, because you then will remember what you were doing in different steps. And somebody else also can look at your code and try to understand what you were doing, right? It shouldn't be that you give a bunch of code to somebody and they really can't figure out what you were doing. So it's very important to write very neatly and kind of comment on the different steps, that not everything, but just the major things that you're trying to do should be listed. And also, sometimes I realize that students are trying to write R code all in one line. I suggest you use the next line. So you can have a comma, for example, and then go into the next line, or you can have a plus sign in one line and go into the next line. And that way, you're not going to have an error when you're trying to run the code or you're trying to knit your Quarto document. Okay, so with that, I will see you in the next video, which will be on data visualization.